The next lecture is on recursion. So before we move on to queues and stacks, we'll just do a bit about recursion and discuss what are the benefits and what are the drawbacks of using recursion versus your iteration. So you must all have written recursive functions like your Fibonacci numbers or your factorial. So what does a recursive function comprise of? When you write a recursive function, the most important thing is that you have your two important parts of the recursive function defined. One is your base case, which is in a way your exit condition from the recursive calls. So you keep on calling the same function and again, and the only way to know when you have to stop is your base case. So in case you miss out on your base case, your system is going to run into an infinite loop and it will eventually crash because it will use up all your memory. So then you have, after the base case, there's a recursive call. So you are calling the same function again with a different value of n. Okay, so now your recursion can be done directly or indirectly. So there are two types of recursion which we define. So there's, in recursion we use the term recursive chain. So a function, let's say ABC, calls itself within the frame of the function or the definition of the function, and there'll be a base case somewhere here. Okay, so in case of the second example here, which is indirect recursion, your ABC is calling XYZ and your XYZ is calling ABC. So in a way there is a recursive call to ABC, but it's not direct now, it is indirect. So this is your indirect recursion. So sometimes when you are writing or maybe you're reading somebody's program that's already written, so this kind of recursion will not be obvious to you when you see the code. So what is the important property? You have to make sure that you do not forget your base case, in which case if you forget, you will have an indefinite sequence of recursive calls. So there has to be a stop sequence to stop your function calling itself. And then you have to know whether your function is using direct or indirect recursion, that there is a recursive chain. So you can have more than one recursive function per se, in the sense, like I said, ABC and XYZ are involved in the recursive chain. So there can be indirect recursion as well. So let's go over to a simple example which you must have done earlier as well. Factorial of a number. Factorial of a number n is equal to n into n minus 1 and minus 2, so on till you get to 1 or 0. Okay, so what is your base case? You keep on multiplying n with n minus 1 and so on till you reach 0. You don't multiply with 0. So whenever you reach 0, this is your base case, you return 1. If not, then this is just an expanded version. You decrement n to n minus 1. You call the same function factorial for the value n minus 1, and then you return n into factorial n minus 1, which is your y. Okay, just a basic example. You can write this and run it to see how it works. Then another example, although you don't need to do multiplication using any recursive call, but just to explain, like I said earlier, in polynomial multiplication is repeated addition. So if you multiply a with b, so you are actually adding a b times. So what we do, we call multiply a with b minus 1 and we add a to it. So we are reducing the problem of multiplying a with b minus 1 now, and your base case is if b is 1. So if a is multiplied by b and b is 1, that means you just have the answer a. So you return a in that case. So this is the condition. If b is 1, return a, else you call the function multiply a with b minus 1 plus a. Okay, this is the shorter version of the same program. We can also write it like this. So if b is 1, return a, otherwise c is your we set it to b minus 1, and then we call multiply a with c, return the value to d, we add that here, and we return the sum. So what happens when there is a recursive call? If you'll read more about it later in your operating system courses. When you have a process running or you have a function running, the function has its own context, in the sense the x in function 1 of the recursive call is different from the x in function 2 of the recursive call. So each function has a copy of its local variables, its parameters, whatever temporaries it has, and it also has a return address. So when you call a recursive function, the second call knows where it has to go back. It returns exactly at the place where it was called, with a value or without a value, and then the earlier function proceeds. So you have to save a complete block of these parameters, local variables, and return addresses for every function call. So that's why your recursion is a bit expensive, in the sense that you are calling, let's say you call the function 100 times, so you have to save 100 copies of the same function. So it is expensive in terms of memory, and obviously it takes time to uh, copy that block for that function, and then when you return, you have to recopy it and set the environment based on your previous function call. So that takes a bit of time. So in case you have an option to do something using iteration, it will be easier on the system in terms of runtime and space. So for many problems which are recursive inherently, it is easier to write a recursive function. So you can you could write a function which will be less prone to error, and you'll have few lines of code if you do it using recursion. It's just re means back and curse means to run. So let's say your factorial, this is just a shorter version of your factorial. I've given you an example here. So you call factorial 5, it calls factorial 4, 3, 2, and 1. Factorial 1 returns 1, so this 1 goes back here, and this 1 then multiplies with the previous n, which was 2, so 2 into 1. So similarly 3 into 2, 4 into 6, 24 into 5, and you get the answer 120 back. Okay, so you can go through many recursive problems. So like I said, there is more overhead, it hampers speed and memory, it can't solve every problem, so not every problem will have a recursive definition. So sometimes you are able to create, let's say for multiplication, we are able to express it as repeated addition, so there is a possibility of creating a recursive function call, but you won't be able to do it for every problem. So, and also what happens in case of recursive functions, when you make function calls and something goes wrong, so it's very hard to debug or decode where the problem exactly exists, because you'll not be able to see anything with recursive calls. So you might try printing, so debugging will be a little different or difficult compared to your iteration. You will not be able to extend the functionality that much because of the recursive nature of the problem. It might be, like I said, difficult to debug. Okay, so the disadvantages, just a quick recap: overhead, hampers speed and memory, it can't solve every problem, hard to extend functionality, and it's difficult to debug and understand, and might cause stack overflow. This is what I want to explain to you. We'll discuss more of this when we actually discuss stacks. So for now, I just want to tell you that when you make a function call, how the copies of the functions are maintained inside the system is that if you are calling factorial n, it is at the bottom of the stack. You can think of it as a stack of plates. So the first plate you put is your factorial n. When you call n minus 1, that goes on top of n, and then n minus 2, n minus 3, so on till you reach 1. And for 0, when it comes back, it will come back to factorial 1. Like I said, if you see this sequence, it's actually, you can think of it as this being the base of the stack. Okay, then you put fact 4 on top of fact 5, then you put fact 3. Okay, let me just go up a bit. Okay, then you put fact 2, you put fact 1, and fact 1 calls function with n equal to 0. So actually when you make, in this case I have put f equal to 1, and when f is equal to 1 it returns a 1, it returns it to this function. So actually it comes back to this return statement here, and then the multiplication happens, the value is returned to this function, this returns the value to this, and this will return to this, and this will return back to the main function, and that's how your recursion is complete. So it grows like a stack, and then it returns back with the stack. Okay, so what is stack overflow? Here the growth is up to 1, and then it returns back. In case you missed on the base condition, it will keep on doing fact n minus 1. It will infinitely go to the negative values, and this stack will keep growing. What I'm placing on top of one another are the copies of the same function. Like I mentioned earlier, each copy has parameters, variables, temporaries, return addresses. So all this is, you can think of it as a separate data structure where all these values are stored, and then they are packed on top of the another, so they are using memory. And in case you miss the base function or you have some error in your program, it will grow indefinitely and it will result in a stack overflow, which will, it is actually stack overflow, which will uh, actually crash your program. Okay, so this is the basic of recursion. What I want you to do at the end of, you can read through recursion, you can read through advantages of recursion as compared to iteration, then you can read what are the advantages and disadvantages of iteration. Then you also go through the towers of Hanoi problem. So I want you to do that as a assignment. So Tower of Hanoi is actually a game where you put pegs on top of one another and you have to move them. It's like a birthday cake. So you have 3 poles, you move these pegs from this to this one using this one as an intermediate, and while moving you can move one at a time, but you cannot put the bigger one on top of a smaller one. That's why we need an intermediate. So everything has to be at one of these 3 poles. These rings have to go in one of these 3 poles, one at a time, and you cannot put a bigger ring on top of a smaller ring. So this, if you see, there's a recursive program written for it, and it simplifies it very easily. You can just Google and go through actually a solution to this. The solution to this problem will be a text-based solution where you tell the user to move from A, all the pegs from A to C. You have to use B as an intermediate, and it will print out all the steps you need to do to move these pegs. There can be any number of pegs. So your recursive nature of the problem is that if there are n pegs, if you move this top one here on B, then your problem B or C as an intermediate. So the solution is you move this to C, then you move these two somehow to this one, and then you move this on top. So you will have the same problem with n minus 1 number of pegs, and that is how this problem will be solved. So I leave that as an assignment to go through yourself. This is an example of recursion. Just see how the program actually works. Okay, so this is the end of your recursion. We'll move on with, because we started picked up the stack topic, so we'll move on to stacks first, and then we'll do queues.